Question number 7. Electric field. Yes, what was gravitational field? Plus 1. Chapter number 6. Gravitational field. Yes, space surrounding some mass, where you can experience the effect of the mass, influence of the mass. That means in plus 1, it was mass, space surrounding this, where you can experience the effect of mass, was termed as gravitational field. So what was the source of gravitational field? Mass. Example is, if you place a ball nearby, it experiences a force and the ball moves towards the center. Why? Because surrounding mass there is a field termed as gravitational field. Similarly, if you have a magnet, near a magnet, you can experience its effect. If you place a nail here, it moves towards this pole. Space surrounding a magnet. This is mass, this is magnet. Was termed as magnetic field. Now, what is electric field? If you have a charge, surrounding the charge, space surrounding the charge. If you place a negative charge here, it will move towards. If you place a positive charge here, it will move away. So, space surrounding a charge where one small test charge experiences a force is termed as, yes, electric field. 2 minutes with you to write. What is electric? B part is what? Comparison of gravitational field and electric field. Point number 1. Gravitational field is due to, yes. Point number 1. Gravitational field is due to mass. There is an object of mass m, and in the surrounding you have a field, gravitational field. We term this as gravitational field intensity. Electric field is due to what? Electric field is due to charge. Say plus q. Surrounding this, you have electric field. Point number 2. Force between the two masses and charge between the two masses. Force. If there is a mass m, another mass delta m, separated by distance r. Formula for gravitational force is capital G, capital M, delta m by r square. Force, gravitational force per unit mass is gm by r square. This was termed as gravitational field intensity, was written as G at any distance r, gm by r square. What is the value of G near surface of Earth? 9.8. Here, If you have a charge, very heavy charge, and you have a very small charge, delta Q, the two are separated by distance r. Electric force between the two is 1 by 4 pi epsilon naught Q delta Q by r square. Force per unit charge delta Q is equal to 1 by 4 pi epsilon naught Q by r square. Force per unit charge is termed as electric field intensity, 1 by 4 pi epsilon naught Q by r square. 3 minutes with you to write. 3 minutes to write. Point number 3. This gravitational field intensity, is defined as, yes, how? Force experienced per unit test mass. What do you mean by the term test mass? This mass delta m is so small that it won't create its own gravitational field. Like Earth is a big mass, cricket ball is a small mass. Gravitational field due to Earth is very, very large in comparison to field due to the ball. So you will assume this is a test mass so that it won't have its own gravitational field, or that value comes out to be very, very small. That is why we write delta m. Equivalent to this is what? Yes, electric field is defined as what? Electric field intensity is defined as force experienced per unit test charge. So here it was test mass, here is test charge. This is delta Q. Electric field due to this heavy charge Q is very large in comparison to electric field due to this small charge delta Q. Fourth, yes, deals with what? Direction. Toward center of M as gravitational field is always attractive. Mass capital M, small m or delta m. It is along, yes, along a line joining the centers of the two. Force on this mass, small m, is towards center of Earth, towards center of M. So direction. Number one, it is attractive. That is why it is towards capital M. Gravitational field at this point, for example, this is an object. If you release it, it moves towards center of Earth. So gravitational field at this point is what? Where is the direction? What would the direction? Towards center of a planet or center of capital M. What would this one? It depends. Yes. Direction. How you find the direction? Take a unit positive test charge. So test charge has to be positive. If the charge is positive, This part, test charge, is always positive. Unit positive test charge. It will move, yes. Positive will repel, so it will move away. So for positive charge, positive Q, it is away from Q, radially outward. If it is negative charge, minus Q, this test charge has to be always positive. Then E is towards. Here in this case, it is away. It is towards. If it is negative charge, it is towards minus Q. 3 minutes with you to write.